Earth's moon. What is the moon like? What is the moon like? For thousands of years, people could see the moon, but didn't know much about it. Galileo's observations were some of the first to show details on the moon's surface. Scientists have since learned more about the moon's features. The moon is dry and airless and has an irregular surface. Compared to Earth, the moon is small and has large variations in its surface temperature. Surface features. As Figure 1 shows, the moon has many unusual structures, including maria, craters, and highlands. This is Figure 1 down below. Maria. Dark, flat areas called maria are hardened rock formed from huge lava flows that occurred 3 to 4 billion years ago. The singular form of maria is mare. Craters. Large round pits called craters can be hundreds of kilometers across. These craters were caused by the impacts of meteoroids, chunks of rock or dust from space. Maria have relatively few craters. This means that most of the moon's craters formed from impacts early in its history, before Maria formed. Highlands. Some of the light-colored features you can see on the moon's surface are highlands or mountains. The peaks of the lunar highlands and the rims of the craters cast dark shadows. The highlands cover most of the moon's surface. If you look at the picture down below, we can see you can see this big dark patch. This would be a mare, or if we're looking at all of them, these are maria. These would be big dark patches of lava, of ancient lava that cooled, flattened that whole area, and left that dark spot. You can see craters. Those are going to be all of the little circular impact points. If you think about Thor and Thor's hammer falling to Earth's surface, when it hit that ground, it made that big bowl shape in the ground. If you've seen the movie Thor, or you are an Avengers fan. But the crater is made from an impact point. The highlands are going to be the lighter spots. We had a picture in class that we looked at, but the edges of craters are going to be brighter, or this kind of area right here is a little bit more elevated and shows a brighter surface, and that's what we call our highlands. Size and density. The moon is 3,476 kilometers across, a little less than the distance across the United States. This is about 1/4 of Earth's diameter. However, the moon only has 1/80th as much mass as Earth. Though Earth has a very dense core, its outer layers are less dense. The moon's average density is similar to the density of Earth's outer layers. Its gravity is about 1/6 of Earth. We talked about this in class as well, but if you have a glass of milk and you pour chocolate syrup in it, that chocolate syrup is going to sink to the bottom of the glass because it's more dense. So if we look at our Earth, and when the Earth was forming, it was lots of hot molten lava, and everything that was more dense would sink down to the center of the Earth because of its gravitational pull. So everything that was more dense came down to the center or to the core, and everything that was less dense sat on the surface. We thought one of the most plausible explanations for what formed the moon was that a large object in space came and hit the Earth, and when it hit the Earth, it knocked off a bunch of material. It broke up the object and broke off the lighter layers of the Earth, and all those little pieces started to orbit the Earth, got caught in its gravitational pull, and eventually the object's own gravity ended up clumping together and forming the moon itself. So now this is what came from the Earth's crust, as well as the object that impacted or that hit the Earth. So everything that was sitting on top of the Earth is what got knocked off. So only that light material, that light crust that was covering the Earth's surface is what formed the Earth, or the moon, which is why the moon is so much less dense than the Earth is on average. Temperature. At the moon's equator, temperatures range from a torrid 130 degrees Celsius in direct sunlight to a frigid negative 170 degrees at night. Temperatures at the poles are even colder. Temperatures vary so much because the moon does not have an atmosphere. The moon's surface gravity is so weak that gases can easily escape into space. So when the moon is getting direct sunlight, when it's in that light, it's hit full force by the sun's energy. It's very, very hot in that direct sunlight. But when we're looking at the shadow, the dark side of the moon, or anywhere that's not hit by direct sunlight, there's no atmosphere to trap, or like that blanket to trap and protect the moon. So all of the heat that hits the surface of the moon, as soon as it's out of that direct sunlight, it's going to be releasing all of that heat. There's nothing to keep it trapped. So it gets very, very cold in those dark spots on the moon's surface. Earth has an atmosphere because the gravitational pull is just strong enough to keep air molecules surrounding the surface of the Earth. But because the moon doesn't have that strong enough pull, all those molecules disappear, so it doesn't have enough gravitational pull to hold an atmosphere and protect it from the sun. So on the moon, it gets very, very hot and very, very cold, where the atmosphere on Earth helps to keep it a little more average. Water. For many years, people thought that the moon had no water, except for small amounts of ice. In 2009, scientists, using data from several space probes, determined that a thin layer of water exists in the moon's soil. The total amount of water is very small, but it is found in many places on the moon's surface. Because there's no atmosphere, it's very difficult for liquid water to stay trapped. Now, if it's frozen in the bottom of the craters or at the poles where it doesn't get direct sunlight, then it's going to stay there in a solid form. It's going to stay there as ice. But when it immediately hits that sunlight, the temperature is going to evaporate that water, and there's no atmosphere to trap it or to keep it close to the surface. Origins of the moon. Scientists have suggested many possible theories for how the moon formed. The theory that seemed to fit the evidence best is called the collision ring theory. About 4.5 billion years ago, when Earth was very young, the solar system was full of rocky debris. Scientists theorized that a planet-sized object hit Earth or collided with Earth. Material from the object and Earth's outer layers was ejected into orbit around Earth, where it formed a ring. Gravity caused this material to clump together to form the moon.